Okay, here's another video building on the last one. Consider the graphs G4, A, B, and C above in the problem above, which, if any, are trees, and draw a picture of the spanning tree for each that is not a tree. Okay, I'm going to go up here, and I'm looking at these four graphs, and I'm going to go ahead and draw on top of them a spanning tree if it's not a tree. Anytime we have a cycle, we don't have a tree. So here, graph G4 has 1, 2, 3 different cycles. Graph A has a cycle here. Graph B doesn't have any cycles, looks like it, and it's all connected, looks like it's a tree. And graph C has a cycle here, has another one here, and has another big one here. Okay, and so this is not a tree. For graph G4, graph A is not a tree. Graph B is a tree. And graph C is not a tree. Okay. By the way, a tree can't contain a loop either. These guys, these little loops here, gotta go if we're going to do a spanning tree. So a spanning tree, almost, there are a lot of different ways of making G4 into finding a spanning tree for G4. And basically you just cut all the cycles. So I'm going to go ahead and draw a spanning tree for G4. And as long as it's connected and contains every node and has no cycles, it's a spanning tree. So there's one example of a spanning tree for graph G4. Next, for graph A, it's not even connected, and so we can't even make a spanning tree out of it. We can't take a subgraph, which is a spanning tree, because it's not connected. Okay. If we were forced to make a spanning tree out of this graph, I suppose I'd fill it in maybe like this and connect that one up like that from D to G. But that's normally when you find the spanning tree, you're starting with a connected graph. And here I'm going to go ahead on graph C and just fill it in like that, and that's a spanning tree for graph C. Okay, so that's problem number 10. Let me do another couple problems here. Well, I'll leave that one.